Hi, in this video we're going to cover Pythagoras theorem on 3D shapes. Specifically, we're going to find a diagonal inside a cuboid using Pythagoras theorem. I'm going to assume you've already covered Pythagoras theorem, so please look up those videos if you haven't already. So we want to find the length of AG in this cuboid. Now AG is the length from here to here, like that, right? Now, how do we do that? Now, the key is to form a right-angled triangle. Now, if I was to add an additional length from here to here, like this, can you see that I now have a right-angled triangle? Can you see this is a right-angled triangle like that? And you can see, look, we've got this right angle here. So I can use this right-angled triangle here. Now we've got one of the lengths of the right angle triangle, we've got this 9, but we don't have this bottom red length of this right angle triangle, do we? But what we could do is we can then use this right angle triangle at the bottom here, so ADH like that, because can you see that that itself is a right angle triangle? It's kind of slightly hard to see, but you can see that, there we go, that's a right angle triangle. So if we look at ADH first, so draw that, so ADH, this is the purple triangle. We know that this length is 5, this length is 7, and we want to find this red length here. Let's call it X for the moment. Now remember how Pythagoras theorem works. You label the two shorter lengths as A and B, and the hypotenuse, the longer side, as C. And then Pythagoras theorem states that A squared plus B squared is equal to C squared. So we do the 5 squared plus the 7 squared, and that's equal to C squared, which is X squared. So we substitute the A, B, and C in with the lengths in our triangle. And then, okay, let's do 5 squared plus 7 squared. That's 74. So 74 is X squared. And then you square root both sides, so X is the square root of 74. Now, you could do that as a decimal, but for reasons which we'll see, I'm going to leave that length of X as root 74. You'll see in a moment. So this X, if I put it on the diagram, we've got root 74 up here. Now we can focus on the yellow triangle. So if we draw that separately, got this yellow triangle, let's highlight it in yellow, and that involves A, H, and G. And what are the lengths here? We've got the root 74 at the bottom. We've got the 9, which is GH. And we're trying to find the length of AG. Let's call that Y, because I've already used X. And again, if we use Pythagoras theorem, we can do, we can make these shorter lengths, let's just call them A and B. And the longest length for hypotenuse is C. So then we've got A squared, which is 9 squared, plus the root 74 squared, root 74 all squared, and that is equal to the hypotenuse squared, so Y squared. Now, 9 squared is just 81. Now, root 74 squared, well, the squared cancels out the square root, so you just get 74. That's why it was a good idea leaving that length as root 74 here, because then when we squared it, it just got rid of the square root. So that is equal to Y squared. So if we do 81 plus 74, that's 155. So Y squared is 155, and therefore Y will be the square root of that. And now we can give our answer the decimal to one decimal place. So the square root of 155 is equal to 12.4 to one decimal place. So that's the answer. It's 12.4 centimeters to one decimal place.